Hey everyone, on today's episode of Careers Out There, we're going to explore careers in chemical engineering. We'll be talking to Joe Sullivan in the Shenandoah Valley of Virginia. Joe's a chemical engineer in the pharmaceutical industry with over 10 years of experience. On every episode of Careers Out There, we explore a career path by talking to a real professional who does that kind of work. And they tell us what it's really like, and then they share all kinds of advice to help you decide if it's a path you want to pursue. So we're helping you find a career that fits you. I'm your host, Mark Luber, and I'll be learning right along with you guys today. Joe's got a lot of great eye-opening stuff to tell us about chemical engineering, so it's going to be a great show. Stick around. Okay, we're back. Joe, welcome to Careers Out There.
Thank you. Thank you for having me here.
Yeah, thanks for being here. So I was telling the audience, Joe, in the intro, that I'm going to be learning right along with them because I know nothing at all about engineering. Really nothing. So I'm really excited you're here. And when we were talking on the phone the other day, we were talking about how this is pretty common. A lot of people don't know a lot about engineering. And a lot of people kind of take it for granted when, in reality, where would we be without engineering, right?
That's absolutely right. I think a lot of people they see products in the marketplace that they could purchase. Maybe from their shampoo to their to some devices they have, like for instance, a lot of devices they're using these rechargeable batteries, lithium-ion batteries, and other things. Those don't just appear after the artists have conceptualized and come up with the design of these wonderful products they want to bring to market, right? Engineers have to make those visions become a reality by applying science and knowledge to bring those products to life. And so chemical engineers specifically, when someone comes along, we might have some chemists, some doctors come along and say, for instance, in my profession in the pharmaceutical industry, this is a drug or a chemical which has certain properties within the body, and if we could just make it on a large scale, we could distribute it to all these people and improve their lives, improve their livelihood. And so this is what chemical engineers do: is they take that idea and say, yes, we have factories, we have big tanks, we have apparatus that will let us make that product on a large scale so that it can be given to many people, right? And so that's what chemical engineers essentially do. And you do that by understanding the properties and the nature of the chemicals you're actually handling. And you begin to see patterns in which they behave as you take them from the laboratory in a flask up to the large scale tank. They may actually behave somewhat differently on the large scale. And so engineers understand that and correct for that, so they can make a product that's needed. So that's, in a nutshell, that's...
So you were telling me, so you were just talking about pharmaceuticals, and you were telling me that with paint, for example, it's a matter of making that paint thinner or thicker, right? So that it responds differently when you're brushing it onto the wall, stuff like that?
Yeah, exactly. People take for granted paint and think it's just another liquid, when in reality, it's quite different from water, if you think about it, and that water would just dribble down the wall and it would fall off your brush. Paint is completely an engineered material so that it's thick. When you dip your brush in, you pick it up and it's thick, and when you push on the wall, you're shearing the molecule, you're shearing the paint liquid, and it spreads easily. It's called shear thinning behavior, and this is a property that is specifically engineered into paint to allow you to get big glops on your brush, but yet spread it thinly on the surface of the wall. And so, I think that's the thing, is all these things are taken for granted by the general public because you don't really get exposure to the level of engineering that went in to achieve the properties in that, in whatever you're talking about.
Right. For some reason, engineering is not sexy. People don't care. So it's your job today, for our audience, You got to make it sexy. So we'll put that pressure on you so that we could turn on a whole future of chemical engineers that are watching today. You told me a really, really eye-opening story the other day that helped me understand engineering a lot. If you could take the story about the paint factory and apply what you just said to that, how you helped the paint company that you worked at by applying these basic foundations of chemical engineering.
Yeah, I mean, so the paint factory story I shared with you the other day is I worked in the paint industry for about a year. Until I was hired, they had basically for, I think about 100 years that site had been there, so they'd never really had a process engineer or even an engineer. They'd had some engineers that are best described almost like they kept the place running. But they never had like a real chemical engineer who understood the nature of fluids. Okay, which is all what paint is, right? When I first got there, and I got to work out in the factory, they had a particular process where they were making white paint. And in the process of making paint, you grind pigment up, and as you grind it more and more, you get stronger and stronger paint, essentially. And they had this tank, and it would take them up to a week of adding the pigment in the tank and mixing it, agitating it with what you can almost imagine like a blender, like blade in there, like mixing it up, this blade that can be lowered or raised, and they would turn it on high speed and it would get mixed up, and then they'd run it through a mill, which is a bunch of balls that crunch the pigment up more, and they bring it back into the tank, and they do that again and again. And they had found that, this process took several iterations of going around that loop until they got the product out they needed for the customer in the end, right? So I said, oh, well, let me look at this. So I took a sample of the paint. I took measurements of the tank. I went back to my desk. I did some calculations. Well, first I measured the paint and its properties, how thick it is, just some general properties, how heavy it is. Then I went back to my desk and I kind of calculated out that they weren't running it correctly at all. And I went back out. I told them to turn down the motor on the tank, and they kind of looked at me like with some like disbelief, and they said, oh, like that, that's never going to work, never in a million years. So anyways, what I had established was that they were running the blade so fast that they had put the fluid into what's called turbulent flow, and when fluid is in turbulent flow, all the molecules in the fluid, and in this particular instance, the paint particles we wanted to get torn apart, are all really just kind of dancing around each other, because you can imagine like turbulence, when you think of things being turbulent, they're flopping all over each other, but they weren't really breaking apart. And so what I did instead was put the fluid in the tank in what's called laminar flow, where the fluid is moving against itself like this in sheets. And in between those sheets, if you can imagine, there's something stuck between the sheets. It gets torn apart. It gets pulled two different directions at once. And that would break it up very efficiently. So I had them lower the speed so the fluid would settle out into this beautiful laminar flow. And sure enough, I was able to grind all the pigment in the tank in like 28 hours. And we just had to do one pass through the mill, we were done. And so they'd gone from several days down to 28 hours. And the look on their faces was like disbelief, right? And
yeah, I mean, you maximized their output. You maximized their output by 7 times.
Yes, it's something close to that. Yes, it was very. Yeah, I mean, and so it was a big thing for me and for them to see the power of understanding core principles at work and then leveraging those to get a better outcome. And again, that's what engineers do: is you take some time to think out what are the things affecting what I'm trying to make, and then you optimize those things when you figure them out, so as to make the thing better, cheaper, faster, stronger, like whatever you're looking for.
And then they saw the value of engineering, and that whole story helped me see the value. So I got to figure that it helps the audience see the value too. So I think you're making it sexy. So let's talk about. I want to get.
I guess as sexy as paint can be,
yeah, exactly. For the audience that's thinking about going down this path, they're going to want to know, well, kind of what's a typical day if I'm working out there. And so one of the things you were telling me the other day is that in a typical day, someone's working in their office at a desk, and they're also working in a lab, and they're also in a factory, and that's pretty typical. Can you kind of explain what's happening briefly in each of those and how that makes up your typical day?
Yeah, sure. So for a chemical engineer, and I will say, like we mentioned, like this is early in my career, especially being in a very strong support position for a factory environment. Typically, the day would start off with coming in, hearing what's happened overnight, because we run 24/7, carrying over the problems from yesterday that we might have encountered. This could be anything from a reaction not going the way we planned, to a pipe bursting because of freezing, to any sorts of issues, right? And sometimes it can be the simplest issue, like a valve not working, that then all of a sudden causes all these other kind of cascade of issues, right? So I need to understand those. Probably in the same trip, we might have taken some samples. I may bring those to like our testing laboratories that would normally run testing for us. Those samples may require special testing that we normally don't do, and I bring those back to my chemists that work in my department with me as well. They're kind of like they're able to run tests that we normally don't do, come up with new ideas, right? And then we might all sit down then in a meeting like by noon or something or 1 o'clock, and talk about the issue and pool our data. Right? Like everyone comes and I might have gone back to my desk while the chemists are running tests and looked up process data, like basically traces of the way temperatures and pressures and volumes and other things that have occurred out there, right? Like see what that data is. We all come together, we reach a resolution on what might or might not be wrong, and then we have an action plan basically to go forward. And so I may go back out now, have to implement what are essentially change controls, we have controlled processes, right? And you're going to want to go out and you're going to want to say, I'm deliberately going to change the process so as to fix it, right? So you might do some paperwork, a little bit of paperwork to implement that change, but then you get to actually see your change happen. You now take some more data, come back to the laboratory again, maybe come back to your desk, look at some process data, and basically see if your fix worked, right? And
Okay.
hopefully, most of the time, you've made the right decision. Sometimes you might have a great idea and it didn't work out. It wasn't the root cause, right? So a lot of what we do is, we're always seeking out what we like to call root cause. So sometimes you think you've found the problem and it's really just superficially the problem, and there's something else going on, right? That you don't know yet, right? Like it might be. There not enough water got in that tank that day, and you might go out and say, "Oh, we just need to turn the water up." But then you turn the water up and you notice that even then you didn't get enough flow, and then you go back and you say, "Well, maybe there's a plug in the line," right? You kind of. I guess that's a very simple example, but they're often much more complex.
No, but that's good. That helps.
You basically you're trying to work through some issues, and as the chemical engineer, you're in all three of those places at any given moment. You don't have a home
if you're running around juggling 3 different environments, it's hard to get bored. You're not stuck at a desk all day, or you're not just stuck at any one thing all day, which makes for an exciting job.
I mean, it's great. Yeah, you're definitely going to be getting some exercise, and you get out to get some fresh air. You're getting out. You're meeting usually on any one day, tens of people. So you're getting a lot of interaction every day with people.
Yeah, and I want to run with that. I want to talk about that for a second, because there's a lot of interaction with other people, and it sounds like from everything you were describing in the typical day, there's a lot of putting your head together with other people's heads. And so there's a lot of teamwork involved. So I want to know, who are these other major team players that you're dealing with? They're not all chemical engineers. So who are these other players?
No, I mean, you actually deal with when you're a chemical engineer, you're gonna have peers, but they're gonna be each working on their own processes, and so I would be working typically with what we call operators or chemical operators. So they're actually out there running the machinery. You're going to be working with safety and environmental, so like industrial hygienists. You're going to be working with the business end, like finance, purchasing. You're going to be working with your raw material people, the people that bring the materials on site. You're going to need to integrate with them and figure out, did the wrong shipment arrive? What's going, because sometimes that tends to be the source of a problem. You're supposed to get this kind of product in and this other kind of product came in. You didn't know it, you might also be working with chemists. I know right now I'm starting a new project where I'm in fermentation. I'm working with biologists. You could be working with people who handle all of our paperwork and essentially librarians almost, and administrative personnel as well. I mean, and mechanics. There's so many people I work with, so many different types of people. It's really hard to almost count them all out because on a chemical site there's so many roles because it's so complex, right? It's just like a city. You can't have someone control all of a city. Rather, it's like a big network of people that all need to find ways in which you interact that creates productive work together, right?
So everyone's an alderman, and everyone's like an alderman instead of a mayor.
Yes, I guess so, yeah.
To run with your city analogy. So you were telling me that there's a lot of different things that you could do career-wise, a lot of different paths you can take career-wise as a chemical engineer. Can you tell us what some of those are?
Yeah. Most chemical engineers are going to start your career off one of two ways: in the laboratory or the design realm, where that might be like working in the lab every day, essentially to test new equipment or to test whether the equipment could be used for a certain process, or to actually sit down at your computer and like design the factory. Or you're going to be starting your career like I described, out in the factory every morning, basically problem solving. So that's how most young engineers start, actually. And other things you might do in that role is like validation work, where you're testing tanks and making sure they perform to specifications and things like this, right?
Yep.
So as you get older, then your options open up a little bit, usually to the standpoint of you can continue to go down those roles. You can possibly become like a managerial position, right? Where you're managing like a number of engineers or managing like an entire process. So you might be managing like an entire factory, or you might be managing a team of engineers that are helping several factories. There's different roles depending on, this varies. Then after that, after you have gone a little farther in your career, you may become a consultant. You may decide that you have developed so many skills over your career that you now can go out and help other people with processes like yours and other companies, right? Or you could become a plant manager. So like someone who is basically managing the entire operations of the plant. And the reason why engineers are well suited to those positions is that we, as I mentioned before, we are often in the center of working with all those different types of people, and you get a really good exposure to all the aspects of running a plant, right? Like, like all the minutia that goes on. And so you're often well suited then to become a plant manager because you just have that base, right?
Right. That makes perfect sense. Yeah.
So that's kind of progression you take.
Right, and the consultant, they could be even like expert witnesses on trials too. I bet that's probably a big.
Yeah, absolutely.
Well, who would you say then should pursue something like this? What are we could combine skill sets, personality characteristics, and interests.
People that find themselves interested in math and science.
Okay.
Well, specifically if they're going to get into chemical engineering, I mean, they should have some interest in chemistry. So, for me, that always manifested itself growing up. I would always be mixing things together, as a very young child. And as I grew older, I began to question whether if I mixed similar things together, that weren't exactly the same as those, how would the end thing be different? How would the end product be different, right? And actually, one of my very first thing is and I don't recommend this, but we used to take apart fireworks when I was younger, and we'd make our own, right, from the fireworks stand.
Right.
And I remember going to the live.
It's dangerous. We want to warn everybody.
Yeah, it's dangerous. Don't try this at home, right?
Don't try this at home.
But what we would do is we would take the gunpowder on sheets of paper, and we would take a file to pennies and nickels and stuff, and you start learning about all these things. So I went and file it into the gunpowder. It would change the color of the gunpowder, right? And I always had a natural curiosity about what would happen if I add this or mix this, what would the new result be, right? So that started leading me in the direction of chemistry. And then when I got into chemistry, I said, you know what? I don't know that I like so much the chemistry field, which is specifically like mixing those chemicals every day in the lab. I really wanted, and I think this comes from my background of always inventing stuff as a child, I wanted to make something of my knowledge. Okay, so I'm trying to give you an example of myself, to give you an idea of the kind of personality would be someone that's curious about things, like how they work and stuff, but someone who also wants to take that knowledge and turn it into something new or something better. right?
Right.
And so for like the gunpowder example is like that was our attempt to make it better, because when we found out, take all this all apart, and most of the gunpowder was all yellow, and we were like, that's boring, right? And so I mean, we were trying to make it better, and that's like engineering. The other thing I mentioned in there several times, the word that kept coming up was curiosity. That's crucial, because if you're out in the factory and you walk past this funny noise that's going whir, 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 and like, normally it just goes whir, right? You want to be the person that goes, I better check that out. Like, right? Like, or even though I'm a little late for a meeting, I'm going to go check that out because that really sounds peculiar, right? Like, that's what most engineers are like. Their curiosity helps drive them to solutions, right? And sometimes solutions to problems no one even knew existed. And that's the key. When you get to be a really good engineer, you get to be better and better at your predictive abilities, and less and less at like your firefighting, right?
Mm-hmm.
Yeah. So you look at a situation and you say, oh, I've seen this situation several times. I think I know what might happen, right? And you then try to avoid that, So these are attributes. That
so the curious mind, the problem solver, and the math and science lover. That's like the great. Okay, cool. So what would you say then is the most rewarding part of the whole career? What would that be?
I think the most rewarding part is solving particularly hard problems that there is no solution to. So oftentimes, like being the first one to discover the issue, like, or to like, I love puzzles,
right?
And especially puzzles. I often take the instructions and I crumple them, I throw them in the trash can, which like someone might think is crazy, but I don't want to ever know the solution. I want to get to it on my own, right? And being an engineer is like that often, like almost every day. Like you're presented with issues every day there's not an answer to. You have to go figure it out, right? So for me, that's the most rewarding thing of all of being an engineer, is that there's not a written script by which you should follow every day. It's not entirely up to you what you do every day, but it's entirely up to you how you attack the problems that are presented to you every day, right?
And that makes sense. I mean, if you're a curious mind who likes problem solving the hard problems has got to be a rewarding part of the job. So that makes perfect sense. It would work like that. What about education then? What should people, I'm assuming if someone's in high school, they should be taking as many math and science classes as possible, right?
Yes.
And then college, I assume if you know that you're interested in engineering in high school, then you should be looking for the colleges with the best engineering programs. But some people don't figure out until they're already at college that they want to pursue that path. So let's say you haven't already hunted down the best engineering college, you just chose a university and you've started school and you kind of are figuring out in college, I want to do what Joe does. What should they do at that point? What should they be studying?
Some people don't have an opportunity to take a lot of advanced math and science in high school.
Okay.
And I like to say that does not preclude you in any way of pursuing a chemical engineering or an engineering degree at all. Okay. The only thing I will say is if those are available at your high school and you find yourself not taking those, that may be an indication that this is not the field for you, right? This is not something that you're interested in, okay? So when you get into college, as far as picking the college, you said a good college, right? I'm just going to say I think a good college would be a college which has a large department of the discipline you're thinking about pursuing. Okay, and you can go look this information up online. So you're going to find out that certain schools have larger departments in like chemical engineering, or have a larger department in like, for instance, electrical engineering, right?
Well, actually, that leads to another question. I'm sorry to interrupt you, but do you have to know when you're starting which kind of engineer you want to be, or can you start off by taking general engineering classes and then kind of select which focus you want?
So if you choose you want to do engineering as a college freshman, you have the option to take Intro to Engineering in your freshman year. When you take that course, you'll be given a sampling of the different engineering disciplines that are available: chemical, engineering, electrical, or mechanical, some other types. And then at the end of that class, you typically will make a choice about the engineering discipline you want to go into, and then your class schedule will be chosen to fulfill the requirements of that discipline, right? So for chemical engineering, you'll be taking kinetics and thermodynamics and other things like that, okay? Um, after that first entry class, after the first entry classes, you still may be available to switch disciplines. So you may have taken some intro classes for engineering. They're not totally worthless, or for chemical engineering, they're not totally worthless to an electrical engineer. You could switch.
Okay.
Okay, and that's usually in your sophomore year. People will make that choice in their maybe the first semester of their sophomore year. After that, you pretty much should probably stick with the discipline you've chosen.
Okay.
Because you're getting into more and more advanced 200, 300, 400 level classes, that are very specific to your discipline. Right?
Got it.
Does that make
Okay.
sense?
Yeah, definitely. And so we've talked about now all the good stuff, and now we've gotten people to the point where they're in school. Let's talk about the dark side, the ugly stuff. What's the biggest challenge of being a chemical engineer? What's the hardest thing?
Most of the processes that you'll support as a chemical engineer are going to run 24/7. Okay, so around the clock, all year long. Oftentimes, being down can mean tens of thousands to hundreds of thousands of dollars an hour sometimes, depending on the value of the product that's going through the train. And so the downside of being a chemical engineer is that you make a commitment essentially when you join a company that you are going to make your skills available to that company for the process, for those processes, right? And so I've had, for me personally, a Thanksgiving dinner interrupted. I had to come up to work to basically get a process running that had gone down during the Thanksgiving.
Wow.
And I've also had a week or two where I didn't see my family except sleeping, because I was working very long hours on a very difficult problem. Now that was very short term. Early in your career, you might find yourself working a lot of shift work, which means a lot of sleep interruption, in the way your natural sleep cycle might be used to, right?
So that could mean like working
those are really
midnight
the downside,
till that would be like working midnight till sunrise, that kind of a thing.
Yeah, that kind of thing. Yeah.
Wow.
Yeah. I mean, where you work extended hours would be like on a very specific problem that is arising, right? When you're working like when I say shift it would be like your shift might be 8 o'clock at night to 6 in the morning or something, or whatever. And then you might work that for 3 or 4 days, be off for you still get off days, but I'm just saying you will be off from the rest of society. So some people like it.
Huh.
I see that as a downside, especially if you have a family. That can be a downside because it can just be difficult to see your family,
Right.
because they're not going to be on that odd schedule, right?
Right. So that's like the early career. That's the early phase where you're building things up. You might have to pay your dues that way.
That's never going to go away. So even later on in your career, because there's always going to be a need for you. And when you work on things that run around the clock all year long, there's going to always be, even later in your career, there's going to be a time when you have to come in an odd time to either fix something or to see something that only occurs like at night. If you were to go out in engineering and that was to be your life every day, I would say you're probably not at the right company. Okay, so just those types of demands are usually short term, and then you can get back into a more regular schedule.
What about the thing that would weed people out? It sounds like, that I always like to say, what is that thing where if you can't handle this, you shouldn't go down this path? It sounds like from what you were saying about just the grueling classes that you have to take to get to the point where you're actually a chemical engineer, it sounds like that would really weed people out, and that if you don't enjoy those classes and you can't get through those classes, then you'll be weeded out before you even are a chemical engineer. Is that right?
Yeah, I'll just give you an idea. Like when I was in school, me and my friends, we would take the classes and they were tough, right? Yeah. But when we would get done with that tough assignment, we'd all have the same kind of response, like, oh, that's really cool. Like, that's so cool that we solved this really tough problem using this really advanced math. But if you find yourself looking at such situations with dismay, then engineering's not right for you at all. Like, you know what I'm saying?
Yeah, that paints a perfect picture. Totally. I wouldn't last 5 seconds in any of those classes. Not because I don't think it's cool, but because I wouldn't even understand it. Everything would go a mile over my head. So I know it's not for me. Finding employment. Let's talk about that. Getting a job after school. Would you say internships during school are an important thing for them to try and look for while in college?
Absolutely. I think, just seeing the candidates come through here, the ones that have expertise from doing summer internships or what are called co-ops, which is where you leave school for an entire semester and you work at a company,
Okay.
those are extremely valuable. So, and that's the thing is there's that old adage that you're like you don't have enough experience to be hired, but but you can't be hired unless you have experience, right? And it's like a catch-22, right?
Yep. It's always out there. Yep.
Co-ops, yeah, co-ops and internships are the perfect opportunity because companies will scoop you right up. You can come and work usually on these really defined, narrow, special projects, which are great because you can achieve like a certain success in just a few months you're there. You're given a very tight goal, and you can get this really nice success and something to claim later in interviews, right? Like you can say, like, as you're interviewing, like, I was on this co-op and we developed this technology, and,
Right.
like it's a nice sharing story to have in your interviews that show people that you've really been in the trenches, and it gives you that experience.
Yep. Gives you an edge up, a leg up on other people. You could help get that first job. That's great. So everybody should do that. They should look into those kinds of opportunities, whether it's co-op, if your school does that, or internships. What about keys to success? I always like to have everyone close this out with this. Take all your years of experience and share some advice with people who are breaking into the career path of being a chemical engineer and help them to kick butt. What are the key things you would tell them?
The key things I would tell a chemical engineer. The first one is to listen to the people who actually work in your process. Okay, so go out, interact with those people on a day-to-day basis, make them your friends. They more than anyone else, no matter what anyone else tells you, they more than anyone else know the process backwards and forwards and what the issues are. And they're going to help you solve problems day in and day out. So that's number one. I think that and if your company offers the opportunity, I didn't have this opportunity when I started here at this company, but at the paint company, I got to work the floor for 6 weeks. So I actually got to become an operator in their, and if that's a possibility wherever you go as a chemical engineer to work, ask for it. Ask to do that.
Because standing in their shoes lets you totally relate once you are on the chemical engineering side, so you can understand where they're at.
Oh, yeah. Not only do they see you as a peer, as an equal, in which case then they're more likely to share issues with you freely, right? And share candid assessments of your great ideas, right? That you're going to come out with.
Yeah.
But it also gives you insight into things you just can't get sitting at a desk or going out there only for an hour or two here and there. When you're out there all day long, you get to see that, like, the nitty-gritty. And I have to say, in the paint plant, like at least 75% of my really good ideas came from that just 6 weeks I spent.
Wow.
Out there. Like I had this running list. So that's another suggestion.
Okay.
Don't be afraid to ask stupid questions.
Right.
I get that, like, young engineers, I think they want to look like they know everything. Trust me, it's no one's looking for that actually at all, number one. And I still don't look like I know everything. Like, I'll tell you what, looking like you know everything actually shuts people down. It makes them feel like not sharing with you, and and so it's much better to play the role of asking silly questions and supposedly stupid questions, because you get to the core answers first, and you make people feel more comfortable about themselves, and they're more likely to share them. So those are some advice that I think people don't hear all the time.
Right. No, that's great. I think that's really helpful advice, and I hope it helps all you guys watching. Please leave your feedback, your questions, and your comments in the comment section below the video there on careersoutthere.com. And Joe, thanks so much for taking the time and sharing all your insight with us today.
No, it's been a lot of fun, and I wish everyone the best out there who's considering being a chemical engineer.
That's awesome. You guys, you could find Joe on Twitter, which is where I found him. Joe, tell everyone your Twitter address.
I'm on Twitter at twitter.com/ITCHE.
Excellent. You guys find him there on Twitter. I'll put that here up on the screen. And you could find episodes of Careers Out There on iTunes, YouTube, and Blip TV. And, of course, at careersoutthere.com. So thanks again for watching, everybody. I'm Mark Luber, and look forward to seeing you guys again soon. Take care.